Hello, this is Ronnie Rauch presenting Aqueous Ionic Equilibrium. Exam 3, Problem 2b. Provide a concise but complete justification for the following statement. If you mix exactly 250 milliliters of a 0.035 molar solution of lead 2 nitrate with exactly 200 milliliters of a 0.047 molar solution of sodium iodide, a precipitate forms. But if you mix exactly 250 milliliters of a 0.035 molar solution of lead 2 nitrate with exactly 200 milliliters of a 0.047 molar solution of sodium chloride, a precipitate will not form. So what is given in the problem? In terms of the initial solution of lead 2 nitrate, its molarity, 0.035 molar, is given, and the volume, 250 milliliters, is given. In terms of the sodium iodide solution, its molarity, 0.047 molar, is given, and its volume, 200 milliliters, is given. And in terms of NaCl solution, its molarity, 0.047 molar, is given, and its volume, 200 milliliters, is given. The problem is asking us to explain why a precipitate forms in solution A, a mixture of lead 2 nitrate and sodium iodide, and why does in situation B, a solution of lead 2 nitrate and sodium chloride. So in step 1, you convert the initial molarity of the lead 2 nitrate solution into the molarity of the lead 2 nitrate in the combined solution. How you do this is you find the number of moles in the lead 2 nitrate solution, and you do that by multiplying the molarity by the liters. This is because molarity is moles per liters, and you need liters, so what you do up above, you can see that I converted the milliliters of the volume into liters, so you get 0.25 and 0.2 respectively. And when you multiply it out, you get 0.00875 moles of lead 2 nitrate. And then after you find the number of moles, you divide that by the total volume, which is 0.250 plus 0.200, because you have to add the two volume solutions together, and I got 0.01944 molar lead 2 nitrate. Then you convert molar of sodium iodide into molar of sodium iodide in the solution, which is the same as before, molarity times the volume, which is, of course, I have to convert it from milliliters to liters, and then you divide that by the new total volume of the solution, and you get 0.208 molar NaI. And then you determine the potential precipitate. So it's lead 2 nitrate plus 2 NaI leads to lead 2 iodide and sodium nitrate. And then you have to determine which are the soluble. One's soluble, one's going to not be soluble. Nitrates are, you have to do this either by knowing the solubility rules, or in doubt, look for which of the two products is at the KSP table. And KSP is solubility constant. If it's in the KSP table, it is the precipitate. And also, nitrates are always soluble. So that means in this case, lead iodide is the potential precipitate. Calculate QSP, and you do this for molecule XAYB. The QSP would be concentration of X to the power of A times concentration of Y to the power of B. QSP of PbI2 is the concentration of lead times the concentration of iodide squared. Concentration of lead is equal to the concentration of lead to iodide, because lead to iodide is soluble, meaning it dissociates fully. And it's the same thing for iodide. And then you plug those values in. Get 0.01944 times 0.0208 squared, and you do the math and get 8.5 times 10 to the minus 6. Then you compare QSP and KSP. The KSP of PbI squared is 9.8 times 10 to the minus 9, which is found from the table. You look at the table, and then you compare it to QSP and KSP. 8.5 times 10 to the minus 6, or KSP, is larger than 9.8 times 10 to the minus 9, or KSP. That means that a precipitate forms. If KSP was larger than QSP, that would mean that a precipitate would not form. Basically, you repeat the same for scenario 2. It's the same thing where you convert molarity to moles by multiplying molarity times moles. Then you divide it by the total volume, which is the sums of the two initial provided volumes. And you get 0.01944 molar. And do the same thing for NaCl, 0.047 times 0.2 liters of the NaCl solution. Of course, remember to convert your milliliters to liters, because molar is moles per liter. And then you divide it by 0.450 liter solution, and you get 0.0208 molar NaCl. And then you determine the potential precipitate, and you write out the equation. Lead 2 nitrate plus 2 NaCl equals lead 2 chloride, and 2NaNO3. And then biosolubility rules, all soluble nitrates are soluble, which means that PbCl2 must be the potential precipitate. Also, it's on the KSP table. And then you calculate the QSP. You do this by QSP PbCl2 is the concentration of lead times the concentration of Cl minus squared. And you can find the concentration of lead in Cl from lead-2 nitrate and sodium chloride, respectively. So it's 0.01944 times 0.0208 squared. And then you get the QSP of PbCl2 is 8.5 times 10 to the minus 6. Then you compare KSP and QSP. The KSP of PbCl2 is 1.17 times 10 to the minus 5 from the table. So 1.17 times 10 to the minus 5 is greater than 8.5 times 10 to the minus 6, which means the KSP is greater than QSP, so no precipitate is formed. What is being asked of us is to rationalize why a precipitate forms in a mixture of lead-2 nitrate and sodium iodide, but not in a mixture of lead-2 nitrate and NaCl. And how you solve the problem is you convert the molarity of each solution provided into the molarity they had in a solution of both of them mixed together. Then you determine the precipitate that will form by using the solubility rule / checking the KSP table. You calculate the QSP, then you find the KSP, and you compare them. And then you repeat for the other situation. In situation A, the QSP is 8.5 times 10 to the minus 6, which is greater than the KSP, which is 9.8 times 10 to the minus 6. Even though in situation B, the QSP is also 8.5 times 10 to the minus 6, the KSP is 1.17 times 10 to the minus 5, making it greater than QSP, which means that the solution will not form. Well, it will form in solution A.